So good afternoon, everybody. And my name is Zheng Wang. I'm not the author of this paper because it's unfortunate that Qian soon cannot be here to present this work due to some visa issue. So I will present this work on behalf of her. And the name of the paper is Transfer Learning for Bilingual Content Classification. This is a joint work of the following authors. And this work has been done when the first author, Qian Sun, did her internship at LinkedIn. And in today's presentation, I will start with the problem statement and then talk about the pipeline to solve the problem. And finally, I will talk about some future works. Okay, let's say a simple example. Let's take this post as a simple example. This person called Steven posted a new status, which is totally fine. And however, someone called Akita replied with a job hunting post here. This reply is obviously inappropriate content and will hurt Steven's experience on LinkedIn. So the trouble is that Akita is a legitimate LinkedIn member, thus we cannot simply block her from the website. So we need a solution that examines each piece of content and selectively blocks only those content that are deemed spammy. So that's kind of spam detection content may be written in any language, such as English, Spanish, Chinese, French. So this problem becomes a multilingual spam detection problem. And the key idea behind this problem is to build one classifier for each language. And then we can get a pool of models. Given a new content, we first detect which language it used and then call the corresponding model to do the spam classification. If it's spam, so we will filter it out. The next, we will move to the model building part. The key question is, the key question we try to address is how do we build model for different languages. So we first start with a Spanish model. And the pipeline can be generalized to different languages. So let's see, here is a formal definition of the specific Spanish classification problem. We have a lot of, so in our data sets, we already have a lot of English contents labeled by the crowdsourcing, our database, which can play the role of training data. And our target data is content written in other languages, such as Spanish. So the task is to classify each new content as a job post or not. So here comes across a problem of the translation. So between two different languages. So how to do the translation? Basically, there are two ways. First is to simply translate the features, so from English to Spanish. But in this case, we will lose some content semantics. And also in some languages, there may not be one-to-one correspondence in words translation. So this will cause a lot of problem. And a better way is to translate the whole content into Spanish. So we can use some available APIs to translate English to Spanish. And based on the machine-translated Spanish content, we generate the features and build the models. So here we show the data property of human-written Spanish data and machine-translated Spanish data. We generate unigram features for both domains. Here are the top 20 significant features for both domains. So we can see clearly that there are certain overlaps between these two domains, but they're not identical. So in other words, that means the data distribution of these two domains are different, so which pushes this problem towards transfer learning area. And here, this figure shows the whole proposed pipeline for the multilingual content classification problem. So we have already introduced the first half of this pipeline, so do the machine translation. So then in the next few parts, I will introduce the transfer learning components in details. And so in the following part, I will focus on the transfer learning part, as it's the key technique section of this project. So in transfer learning, the basic setting is that there are two domains. The data in one domain is different from the other domain. So we try to borrow the knowledge from one domain and apply it to another domain. So in our problem, the machine translated Spanish content, which is the domain T, the left domain, and are different from the human written Spanish content, which is domain H. So what we need to do some modification for the machine translated content and to make the final learning result more accurate. And for this target, we have proposed two-stage algorithm to do the transfer learning. So each stage will work, but the combination works the best. The first stage is called the KMM, so it's kernel mean matching. This idea is adopted from an existing work. And the basic assumption behind this idea is domain differences lies mainly in marginal distribution other than the conditional distribution. And by reweighting the sample of the first domain, the domain T, so we try to minimize the differences of the marginal distributions. The formulation is actually a QP problem, so after expansion. And we can use gradient-based algorithm to solve it efficiently. After that, we can learn a model based on the weighted samples in the domain T and apply this model to the domain H. And in the first stage, we don't need the label information in the target domain. But so usually we will have a small portion of the label data in that domain. So can we improve the model we have learned before? So here we adopt adaptive learning or incremental learning idea. We can slightly modify the model learned from stage 1 by a small perturbation delta by using supervised learning on the available data in domain H. The modified classifier is the final model we can use for Spanish spam detection. Okay. And here, let's see some experiments. So in our experiments, we have 12,000 content translated Spanish data, as well as 12,000 human written Spanish data. But in the human written Spanish data, we only have 15 label samples. All others are unlabeled. In order to show the advantage of the two-stage algorithm, we compare it to three methods. First method is the baseline, which means we learn a classifier on domain T and directly apply it to domain H. The second one is to only apply the kernel mean matching on domain T, then build a model and apply it on domain H. The third method is only use adaptive learning without kernel mean matching. So here shows the experimental results. In the first experiment, we generate 1,000 features for both domain T and H and use the intersection of 629 features as the feature space. And for the same precision, so our two-stage algorithm achieved the best recall results. We also show the experiments with ROC curve. So from the ROC curve, we can also find that the two-stage algorithm works the best. And the second experiment, we generate 2,000 features for both domains and use the intersection of 1,216 features as the feature space. And this showed the similar results. So the two-stage algorithm also achieves the best recall results with the same precision. And here's the ROC curve results. And so you may notice that in the first stage, though we don't touch the label information in domain H, we still need the data in H because we need to do the kernel mean matching. So how many data do we need to do the weighting? Of course, the more, the better. And the good thing is that even with small sample size, we can did this work as long as they are balanced. So you can say we can use only 50 label samples to do the kernel mean matching. We can get a pretty good recall results, about 0.7. Okay, so that's what we have done in the paper. And in the future work, we will apply this idea to other type of spams in other languages. So thank you.
So is this a deployed or an emerging paper?
It's deployed, I think.
It's deployed at LinkedIn. So can you talk a little about how it's deployed and how it's used? We didn't hear anything about that yet.
Sorry, because this the company things, I don't know the detail of how they deploy it because I'm not in LinkedIn. So, but I know this should.
Anybody want to try generating some Spanish spam on LinkedIn now to see what happens? Do we have any other questions from them?